this video we are going to see how actually blurring works and also create a algorithm from the scratch to see how step by step process happens and what are the maths and calculation behind it. So let's get started. So first we take an image and get the its pixel values. Each pixel have three values, that is RGB, red, blue, greens. These are known as channels. Now next step is to get the three RGB values separate. We get the red channel, green channel and the blue channel. Now in the next step we are going to start with the red channel. We will do same thing for all three channels, but let's see what happens to one red channel in the separate. Nearest all channel values will be in the padding channel only. So we are taking a region, and then in the middle one, for the middle one we are going to take the average of all other pixel value around it. So what happens, middle pixel will be average of the other pixels around it. So this will make the image blur. How? Because what happens, your corner sharpness will be decreased because one pixel have the average value of others, so image will be blurred. So what we are doing is we are multiplying it with the 0.1, why 0.1, to average it out, because when we sum that we need a average. So before that we are going to multiply it and then we are going to sum it out. So we get this 114 value. And one thing is, you were saying why it is compulsory to get the multiply with the kernel. Why we can't just divide it by the 9 or the value of number of pixels in it? Because when you are going to do a Gaussian and that blurring feature where you want certain pixel to be more highlighted than the other or certain pixel to be more blurred than the others, you will need to have a actual kernel values to be variable. These values will be different, then you get the different pixel get the different blurred. So basically we are taking the average of each pixel and by selecting the region. Now next step, what we are going to do is we get the values from this boxes, and for each boxes we will get the values. So these values will look like this. On the screen you can say this is the actual your value will be after this calculation. This will be our matrix, you can say 5 by 5, and same thing we will do with the green channel and the blue channel also, and then combine all three values. So this is the way how actually blurring works. Now let's move to second part. We are going to write the code from the scratch, and we are at the VS Code, and I'm going to create a new file that will be a Jupyter notebook. You can use the online Jupyter notebook lab, or you can say you can use that one also. And we are but we are going to use the VS Code, which is more easy to use, you can say. So I'm using that one, and here we type the name of the file, that is blur image. I have named the file name is blurred. Now we are going to write our code. First of all, what we have seen, we have to get our image also. So we are going to have the image we were seeing on the video also in the previous section. Now we are going to import it, or we can say we are getting the pixel values from it. So for that we are going to import a library. If you don't have the downloaded, then you can type the pip install. We have to download library for that. So CV2, it's for the image, you can say taking the image to the pixel values, and second will be matplotlib for the rendering, or you can say plotting the image, and third one will NumPy. That is the common things. So we are going to run it this, and I have already run it, or it is already installed in my system, so I can delete it also. I have skipped the process, and now we are going to write our command. And if you don't have that, you can run that command and wait for the installation. Now import CV2 for the image rendering, and matplotlib, import matplotlib matplotlib.pyplot. It is pyplot as PLT. This is common thing. Why you're saying this is only for because we have not started the terminal again now. We were doing the pip install, for that why it is saying the right, nothing worry. Now next step is we are going to plot the image first of all. So image img equals to the cv2.imread, which is reading the file, image file, and what is the path of the file, which is in the string form, and write the file name image jpg. So we are going to write the name image.jpg. Now if you run this command and let's print that one, what we are going to see. So when you run this command, you are going to get a array, that is array form of an image. We were seeing in the image also now that these are RGB values from the image. Okay, this is the RGB values. So what we are going to see, it is a pixel values. So you can also write the values, and here we are importing the libraries only. So you can write the comment also, library. This is a better way to write. Next is when one thing is to remember, that when you plot or get the read the image from the file using the cv2, it gives you image in the form of BGR, not RBG. That is BGR, yani ki blue, green and red, not the RBG. So what we want the RGB image now. So for that we have to convert. Let's first of all see how it shows our image, how it gets. So this image will be a different colors, not RGB, it's a BGR. So something will be different in this image. So let's see how let's plot plt.imshow, that is image show, and what image, img, and plt dot show, that will show our image. Let's run it. When you run, this is the image. This image and the actual image are different. Why? Because this is the BGR image in this section, and this is the actual RGB image. So what we are going to do, basically we are going to nothing but sequentialize the RGB values. Like in this array we have BGR. So first value of the array is B, then G, and the R. So what we are going to stretch is RGB image equals to the cv2 dot, we are going to convert. So cvt color bracket image, and in which format? So cv2 dot color color, color, then BGR to RGB. This is the format. And what we are going to write the command. What we are doing, BGR to changing to RGB. Now let's run the command. Now we are getting the same image, is that is actual image. So now we are getting the actual image here. We are going to create a kernel, that will be kernel, and before kernel we have to mention the kernel size also. So kernel size is, what is the kernel size? Basically that one, that 9 pixels kernel, that is 3 by 3 kernel. Same we can assign the any values to the kernel, and what it changes, basically if you change the size of the kernel, then blurring will impacted. If you increase the kernel size very big, then what happens, the image will be more blurred, because the more sum it will take from the farther pixels, the more it will become the blurred. So kernel size, you can say k equals to the, let's say start with the 3 by 3. So we are going to assign it 3. So this is the kernel size. You can write here also command. Now what is the kernel? This is the kernel with the values of the 1. once and 1 by 9. So we are going to create kernel, you can say NumPy. Here you are, we are using the NumPy array. So for using that, we have to import also. So let's import it. Import NumPy as np. Now we can use it once, that is once, and in that we are going to put the kernel size k by k. Means k by k means you are going to 3 by 3 kernel, and with the data type you can put any data type. Generally we put the float 32, that is the most common, and it get better better values also. So float 32, and after that what we are going to do is divide it by the k into k, that is k. And what it will do, it will give you 1 means once, so it will give once this size of you can say matrix, and divided by the k by k, so it will give 1 by 9 a matrix of 3 by 3 pixels. So you can also print it. So see how what it actually returning at us. Float 30. Okay, there is np numpy dot float. Now it will return you actually values. Now what it giving, 0.1 we were discussing about that also. So it will basically what it is doing, like average you divide the values 9 3 9, we are taking the 9 values and summing it out and divided by 9. Same dividing it happens 1 by 9, you are multiplying with the value, and after that you are going to sum. Same thing is happening as we do average. Now we are getting the, now we have to mention the our blurred image pixels also, or you can say matrix. So blurred image matrix will be our, you can say numpy dot zeros like image. So it will return a 0 values of size, image size matrix. So image size matrix with the value of 0. What is saying, zeros like no attribute to the numpy. 0 side, once again spelling mistake is e, no need to e, and now we are going to get the values. Now we are getting the image values, but in that all pixels are or values are 0. Okay, same size of the matrix but value of 0. Now next, now we are going to actual work. What is the actual work? Basically we are going to now same thing how kernel was moving now. So for each region we are going to select each channel, then for the each region we are going to multiply or taking the average, you can say. So now loop, this is the going to be our loop. Loop will be for I, or you can say C channel in range. In range, how many channels are there? So we also know 3 channels, so we are going to take the 3, and for each channel now we are going to take a padding around it. Now we need a padding, first of all we have done seen already now. So we are going to pad. So padded image, you can say padded padded image equals to the, what will we get, numpy dot pad. There is a option called numpy dot pad. It will pad the image, padding, give the padding to it. Now we are going to take image and this comma this, and basically C. So which image is going to pad it? Then C, means this is the this channel, for this channel we are working. So all that value which have the C equals to the that value, we are going to pad that image only. Okay, so for that we are going to pad it, C values, comma, and pad width. We have to give the pad width. Pad width will be self dot pad, or you can say normal, pad. How much value you want to? Generally we need a padding of same, you can see, of the half, half ले सकते हैं, we can take the half. So padding will be let's assign the value to pad, pad, or you can say padding equals to the k divided by half. You can take the half of the k value to get the actual where you will not run out the size. This is the good way to assign the pad. So pad width, then padding. Next is we have to plot the mode. We have to assign the mode now. Which mode? It is an edge mode. We have already seen the edge mode, means where all pixel values will be equal to the padding values, or actual values will be equal to the padding values of the corners. So it will be much better visualization for the edges also. So ये edge को better करेगा. So next what we are going to do is, for now we are going to first row and first columns. So for I in range, we are taking the first value from the row. Now we are going to take the select the region for that. Region means a area of the pixels where we are going to multiply that kernel. So padded image, then inside that I plus k, because we are taking the k values till the k values, means kernel size, then j till the j plus k, and this is the our region we have selected. Now we get the region. Now we are going to assign the values. This is blurred value, which we have assigned 0. So now we are going to assign that blurred image will be values of c, I, j, all three values, to I, then j and c. For the this channel, this row, this column and this row will be the value we put here. This is basically we are assigning the values to the new image, blurred image. We will get that actual last blurred image. So for that we are going to multiply the, so np sum, we are the summing, and which whose sum? So for summing is region into kernel. So region into, and now this is our blurred image loop we have created. Now when we run, let's see any problem arises. Is there any problem? Tell me any problem is there. Let's see. No. Now it runs successfully. Now we can plot our blurred image. Now we get the blurred image. So for that we are going to plot plt plot I am show which is blurred image and plot show. Let's run it. Let's see. And now this is much blur than actual ones. You can compare it. This is less this is actual image, this is the blurred image. If you want more blurred, then you can change the size of kernel. Let's change the size of, 1 second, implit, where is it? Okay, I am so plt. Okay, there is no implit, it is plt dot show. Now we are going to restart. No need to restart. Let's run it. Now we get the our blurred image.